and welcome back. So today we are going to start a new chapter, chapter 3, which is on measurement of resistances. Okay, so chapter 3, resistance measurement. Okay, and particularly we will talk about low and high resistance measurement in detail, because so we will see that measurement of low, low may be something like about 1 ohm or less. Okay, so you need not remember the values like what is called a low resistance. So we will understand it in more detail soon. So we will see that the measurement of low and similarly high may be several mega ohms. High resistance is a bit difficult. Okay, is difficult. There are some issues and we need special care about that. Okay, so this is what we will learn in this chapter. So this chapter is on measurement of resistance. So let's begin with a very simple idea. Suppose I have a resistance and let's call it Rx. X once again stands for unknown, and the idea is to measure the value of Rx. How do we measure? So we have a say voltmeter and an ohm and an ammeter. Okay, there is no ohm meter right now. Okay, so we have a voltmeter and an ammeter. We want to measure this Rx. So the goal is to measure resistance with a voltmeter and ammeter and an ammeter. Okay, now how do we do that? So we need to apply Ohm's law. So what we will do, we will connect some voltage source across this resistance. Okay, and then we will measure this voltage across this resistance with a voltmeter. So this is the symbol of a voltmeter, a V inside a circle. So this will give me the voltage across this resistance. Okay, and then I will measure the current through this resistance. So what I have to do, I need an ammeter. I have to insert it in series. So we know that ammeters are connected in series. So let's connect an ammeter. The symbol is like this, as A inside an circle. So this ammeter will measure this current I, and this voltmeter will measure this voltage, call it V. Okay, so and then we can estimate Rx as using Ohm's law, the voltage divided by the current. So if this voltage as given by this voltmeter is equal to V, and if the current is I as shown by this ammeter, then we can say that Rx is V by I. This is from Ohm's law. So simple. But there is a catch. What is that? Observe, the moment I have inserted this ammeter in this circuit, this voltmeter is not measuring the voltage across this resistance. It is actually measuring the voltage across the series combination of this ammeter and this resistance Rx. Okay, so note or the problem, the voltmeter is not measuring the voltage directly across the unknown resistance Rx. It is measuring voltage across Rx and ammeter in series. So it is measuring the voltage across these two, across the series combination of these two. Okay, so this voltage is not the voltage across this resistance. So there is an error, because according to Ohm's law, Rx is, this is true only if this voltage is the voltage here across this, call it Vx. Okay, so true Rx, okay, true Rx is Vx by I and is not equal to V, that is the voltmeter reading, by I. So there is a problem. Now can we solve it? So the problem is due to the fact that the ammeter is after this voltmeter. So can we instead connect the ammeter, maybe say here? Okay, can we connect it here so that the voltmeter is not affected by the voltage drop across the ammeter? So let's try that. So let's make another circuit. Okay, so the previous circuit was like this. This is the previous circuit. Okay, let's try another circuit. Let me put the ammeter before the voltmeter like this. Okay, now it's fine. The voltmeter reading is truly the voltage across this resistance, okay, because the voltmeter is directly connected across this resistance. So this circuit seems like it's better. Okay, so for this circuit, voltmeter reading is truly the voltage across the resistance. But for this circuit, it was not so. Voltmeter reading is not the voltage across Rx. Okay, so this circuit seems better, good, but there is a problem. The problem is that now the ammeter, the current through the ammeter, if this current is I, is not the current which flows through Rx, because part of this current I goes through this voltmeter and part of it goes through this resistance Rx. Okay, so this circuit has a problem. So this circuit, in this circuit, ammeter reading is not same as the current through Rx. But let's see the previous circuit. In the previous circuit, the ammeter was fine, because whatever current goes through the ammeter, the same current must go through Rx. So here ammeter reading was fine. Is the same as the current through Rx, current in Rx. Okay, so in this circuit the ammeter reading is fine, it's okay, it's exactly what we want, but the voltmeter reading is not what we want. In this circuit the voltmeter reading is exactly what we want, but the ammeter reading is not so. So neither of this circuit is good, is perfect. But ideally, now let's think of an ideal situation. Okay, so ideally an ammeter should have very low resistance. So ammeter resistance should be very low. Okay, therefore the voltage drop across the ammeter should be negligible compared to this Rx. Then okay, then this voltmeter reading is fine. So it is measuring almost the same voltage as Rx. So ammeter resistance should be very low compared to Rx. Okay, so let me write this ammeter resistance as Ra, A for ammeter. Okay, so Ra, ammeter resistance, should be very low compared to Rx, and then this method is okay. Not perfect though, but it's okay. This method is okay, acceptable. Okay, because then the voltage drop across this ammeter will be much lower compared to the voltage drop across Rx. So voltmeter reading will be almost same as this voltage drop across Rx. Similarly, if I have a near perfect or very much ideal voltmeter in this circuit, okay, so for ideal voltmeter, what we have, the resistance of a voltmeter, call it Rv. So this is voltmeter resistance, and this should be very high. We have seen this before when talking about ammeters and voltmeters. Voltmeter resistance is very high, ammeter resistance is very low. So Rv should be very high compared to Rx. Okay, so why compared to Rx? Because if this Rv is very high compared to Rx, then most of this current I will flow through Rx and very little amount of current will go through this voltmeter, because according to the current divider rule, this current we can write as I multiplied by Rx divided by Rx plus Rv. Now if Rv is very high, then this current will be almost equal to 0, and this current, according to current divider rule, this is I multiplied by Rv divided by Rv plus Rx. Now if Rv is very high compared to Rx, then we can ignore this Rx, and therefore this will be almost same as I. So almost the entire current goes through Rx, very little amount of current goes through voltmeter. So then the ammeter reading will be almost same as the current through the resistance. So then again then this method is okay. Okay, so that means it depends. So if I have to use a voltmeter and an ammeter to measure the resistance, an unknown resistance, then which circuit I will choose, that will depend on the comparative value between the Rx and RA, Rx and RV. So if, let me write, if Rx is much higher than RA, okay, if Rx is much higher than RA, then choose this circuit. This means this circuit. Okay, so because then the voltage drop across the ammeter is much lower compared to the voltage drop across this resistance. Similarly, if I have Rx much less than RV, then choose this circuit. This means once again this circuit. If this resistance RV is much higher than Rx, then most of the current will go through Rx, and this method is acceptable. Okay, so depending on the value of the resistance, we may decide which circuit to choose. So to make it more clear, maybe we should take an example. Okay, so let's take an example. Okay, suppose I have a voltmeter with say RV, internal resistance of the voltmeter, equal to, let's take it 1 kilo ohm. Okay, and an ammeter with ammeter resistance RA equals, say, it should be small, let's take 10 ohm. Okay, so we are taking a small value for ammeter resistance and a large value for the voltmeter resistance. So this is 1 kilo ohm, 1000 ohm, and this is 10 ohm. Now if we have an unknown resistance Rx, okay, whose value is we know it's around say 10 ohm. Okay, so if we take if you have a resistance whose value is approximately 10 ohm, then which circuit should we choose? Then the question is which circuit to choose. Okay, so let's try two circuits side by side. So one circuit is like this, a voltage source, then let's take a voltmeter, ammeter, resistance Rx. So this is one circuit, ammeter resistance is 10 ohm, this is 1 kilo ohm, and this is say 10 ohm. Okay, and let's choose the other circuit, for which we will have the ammeter before the voltmeter, so that the voltmeter reads the correct voltage, but the ammeter will read erroneous current. So this is around 10 ohm, this is 1 kilo ohm, this is 10 ohm. Okay, now so let's find out what will be the measured value of Rx in this circuit. Okay, so if we call this current as I, which is flowing through this resistance, okay, if this current is I, then the voltmeter reading this will be equal to the total voltage drop from here to here. That means ammeter and resistance in series. So this will be this Ra plus Rx whole multiplied by I. Okay, so this will be the voltmeter reading, and the ammeter reading is the current, is same as the current that flows through the ammeter, so that will be I. Okay, so therefore estimated or calculated value of Rx, this will be same as the voltmeter reading divided by the ammeter reading. Okay, so this then we can write it as, so voltmeter reading is same as Ra plus Rx in multiplied by I. So let's write it Ra plus Rx whole multiplied by I divided by this ammeter reading. So let's write it as an I. Okay, now this 2I cancels. Okay, so then this is equal to Ra plus Rx. This is the estimated value of Rx, and true value of Rx is Rx itself. Okay, so true, now the error, so say percentage error, which I define as estimated Rx minus the true Rx whole divided by true Rx. Okay, so then this will come out to be, so estimated Rx is Ra plus Rx. So Ra plus Rx minus true Rx is Rx whole divided by true Rx is Rx. So this Rx cancels, this becomes Ra by Rx. Okay, multiplied by 100%. So into 100%, this will be equal to into 100%. Okay, now if we put the values, Ra is given as 10 ohm and Rx is also 10 ohm, so this will, the error will be 100%. So 10 by 10 into 100%, so this will be 100%. It's a huge error, 100% error. So estimated value will be actually Ra plus Rx. So this will be actually 10 ohm plus 10 ohm, 20 ohm. Okay, double of the true value. So we are, what we are actually measuring in this circuit is not Rx, but the series combination of Ra plus Rx. See, this is the series combination of Ra plus Rx. So the error is huge. So this circuit is not good. So this circuit is not good. Cancel this circuit. We will not use it. Now let's see what will be the error in this circuit. Okay, so for this circuit, say now the it's easier if we start our calculation assuming the voltage across the resistance to be V. Okay, so if this voltage is V, then the voltmeter reading will be how much? So this will be definitely V, because it's directly across this voltage. So this will be V. Okay, and what will be the ammeter reading? Ammeter reading so this will be same as the current that flows here through the ammeter, call it I. Okay, so this will be same as I, whatever this current is. And what will be the value of this current? I. So this I will be same as this current, call it IV, voltmeter current, IV. So the current that goes through the voltmeter plus Ix, which goes through this, call this current as Ix. Okay, so this current I, so it has two components, IV and Ix. So I is this. Now let's find the value of IV and Ix. So IV, so that will be this voltage V divided by this resistance. So it will be V divided by voltmeter resistance RV, and this will be V divided by the unknown resistance Rx. So this will be ammeter resistance. So then the estimated value will be then the estimated value of Rx, this will be voltmeter reading divided by ammeter reading and then this we can write as voltmeter reading is from here V, ammeter reading, so that will be this V by, so this quantity, this is ammeter reading, so let's put it V by RV plus V by Rx. So V you can cancel from numerator and denominator, so this will become 1 over 1 by RV plus 1 by Rx. So this is nothing but Rx RV divided by Rx plus RV, which is nothing but the parallel combination of Rx and RV. Okay. So what we are actually measuring is not Rx, but the parallel combination of Rx and RV. This will be same as Rx only if RV is much higher than Rx, then the parallel branch can be ignored. Now, so this is the estimated value, and the error, how much will be the error? So this will be, so let's take this formula, estimated value minus true value by the true value, okay, multiplied by 100%. Okay, so estimated value we can write it like this, Rx RV by Rx plus RV minus true value is Rx, okay, then whole divided by Rx into 100%. Okay, so this will come out to be, so Rx you can cancel, so if you simplify it will be RV by Rx plus RV minus 1 into 100%, and this will become, so if you simplify it, it will become minus Rx by Rx plus RV into 100%. Okay, this minus sign you can ignore because we are interested about the magnitude of the error, whether it's positive or negative error, that's right now not so important. Okay, so this will be Rx by Rx plus RV, and this will be close to 0 only if RV is much higher than Rx. And now if we put the values from here, so Rx is 10, RV is 1000, then this will come out to be how much? So this will come out to be, so let me make some space by erasing one step, and So now let's put the values. So Rx is 10 by, so this is 10 plus 1000, so 1010. I'm ignoring the minus sign, or we can put it. So this is this much into 100%. So let's put 2 more zeros for 100 and percent. So this is like 1000 by 1010. So this is less than 1%. Okay. So this is a better circuit for this particular value of Rx. Okay. So observe, so we have chosen Rx to be similar as Ra. So this circuit is not good, but Rx is much less than Rv, so this circuit is good. So this circuit can be used. Similarly, so I'll give you a small homework maybe. So if we had, say, Ra equals 10 ohm as before, Rv equals 1000 ohm as before, but Rx equals, say, around 1000 ohm. Sorry, this is not volt, this is ohm. Then you can show that the second circuit, so the first circuit will be better than the second circuit. Okay. So that the first circuit will be better than the first circuit. Sorry, second circuit. Okay. So in that case, this circuit will be better than this circuit. So that is a homework, and I'll be very happy if you do this homework. You can share your result, your calculation in the forum. We'll be happy to check that and correct that if required. So please do this homework. Thank you. We'll meet in the next video.